Hi, everybody. Welcome. Thank you, by the way. This is arguably the most important slide because it's where you're going to find the details for the rest of the conversation. So take a screenshot of that screen, please. Find us online, Twitter, LinkedIn. I don't know. What are you all using these days? Anybody still using Twitter? Yeah, no? LinkedIn? I use LinkedIn a lot. That's gotten to become... Blue Sky's pretty great. I use LinkedIn a lot because it's where everybody is nowadays, it seems like. Oh, there's everybody.
I try to stay off the internet because that's where the viruses are.
That's true.
Yeah.
It's true. So, yeah. Anyway, there's the codes here. Okay, we're going to go through a lot of stuff, and there's code for you to follow along. It's not good code. I'm going to tell you that. I wrote it, so just keep that in mind. But there it is, okay? It's ready for you. Look, you're Rob Winch.
I am Rob Winch.
And I'm Josh Long. Very grateful that you're all here. How you all doing? You having a good time so far? Okay, good. Let's see. Disclaimer.
That's all we need.
Just want to make sure you've all read this.
If the code doesn't exist, it might not ever exist. That's kind of the summary.
Yeah, there's a EULA that we need to be on. I'm not sure if it's actually a EULA, whatever. Please read this and then moving on. Okay, authenticate.
Yeah, so thank you for joining us. I'm Rob Winch. I'm the project lead for Spring Security. And my colleague here, Josh, is going to be driving a lot of the coding. But for now, I wanted to get a quick show of hands. Who here has used Spring Security before? Good. Good show of hands.
You don't count, Joe.
And I like just a little bit more information. Who here has used Spring Security since before the namespace configuration existed? Anyone?
Wait, oh yeah, like a
CG? Well, the CG was, you spoiled the next spot, but no one raised their hand. So who's used a CG security? Okay. All right, so we got, who here has used XML with Spring Security? Maybe do that one. XML? Okay, a few hands, okay.
It's weird,
so we got a lot of modern, I like that, a lot of modern security practitioners.
I like that too. Bear in mind, up until Spring Boot, Spring Security was the #2 most widely used Spring project. Because a lot of people, it brings in Spring to use Spring Security.
Yeah.
Though, strictly speaking, you don't need to use Spring Security in a Spring app.
Yeah, you don't need it in like a Spring MVC or whatever.
Right, it can be a servlet or some other, back in the day, it might have been struts or something,
Yeah. So it seems like everyone's pretty familiar with Spring Security because of the show of hands, but at a high level, Spring Security provides 3 things: protection for common exploits, authentication, and authorization. And what do I mean by authentication and authorization? Authentication is the who. Who's trying to access a particular resource? Authorization is, given I know who, are they allowed to access it? And today we're going to be exploring a little bit of each, but we're really going to be kind of focusing on the who and identifying how we can authenticate users in various ways and then tying it together through some microservices. So without further ado, I'm going to hand it over to my colleague here.
Okay. Let's get underway here. Okay, so we're going to build, as usual, some software to demonstrate the concepts that we're going to look at today. And we'll do that, of course, by starting our journey here at start.spring.io. This is, of course, my second favorite place on the internet. What's my favorite?
Production.
Exactly. Thank you. So we're going to build a simple application here just to look at some of the concepts in terms of Spring Security. We're going to call the service auth because I'm great with names. Great with names. I get that from my dad. My dad was great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, great with names. So we're going to bring in the authorization server. We'll bring in the web support. We're going to bring in Postgres, and we're going to bring in JDBC. And I think that's...
Yeah.
That feels about right. Okay, we'll hit enter. Very importantly, we're going to use the latest and greatest version of Spring Boot, the latest milestone of Spring Boot, okay? We're trying to stick to the latest and greatest wherever possible, so make sure you've got that. We've also got living on the edge. Yeah, well, not even the edge, it's a milestone. It's like a snapshot, right? Yeah. Come on, that'd be weird. No, and then we have the choice of what version of Java to use. And obviously we have 3 radio boxes, but only one valid choice here, right? The current version of Java is Java 24. That won't be so for very long though. Next month, in 22 days, Java 25 will be here, at which point that will be the only acceptable version of Java to use, right? It is technically superior in every way. It is faster, more secure, more performant, more operations friendly, more robust, more scalable. In every way, it's technically superior in every way.
Number.
And it's bigger, and it's also morally superior. okay? You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Use at least Java 24 and ideally Java 25. And also mathematically, we can all agree Java 24 is 3 times Java 8, right? That's just simple math. It's just simple math. There's no arguing about this, okay? It's just, there's no reason to ever be using anything less than Java 24. So we keep these other radio boxes here just to see who makes terrible life decisions, okay? These are not ever meant to be clicked in any context whatsoever, certainly not in front of people you care about or want to have respect from. So we're gonna use Java 24, hit generate, and open this up, okay? And we're gonna build an application, a simple application with a simple controller that will demonstrate some concepts. So I think the first thing I need to do is to refactor our little property file. Is that true? That feels like it's true.
Yes, that feels right.
Okay, good. And get rid of that. So Spring application, name is, nope, come on, Josh, you can do this. There. Okay, good. So we're going to build an application, simple
Want to
controller.
do some SQL properties in there while we're there?
Yes, you know, we're going to connect to a data source. I've got a database running behind the scenes there. Thank you for that. Yeah. URL, JDBC, Postgres, QL, localhost, my database. Username is my user, and password is secret. Now, look, would I ever put this in a real production app like this?
Is that big enough for people to see?
Can you see that in the back, in the nosebleed section?
Might.
How's that? Everybody can see that in the back? Okay, good. Okay, so we've got this, and we're going to build a simple controller that we want to demonstrate, we want to use to demonstrate who's logged in. So, hello controller, right? Okay, at get mapping, map, string, hello, and we'll inject the current principal, the current authenticated user, map.of, name, principal.get name, okay? There we go. So let's go ahead and set this up. Now we have security.
Yeah.
But what if, will somebody be able to get to that endpoint?
Yeah, let's go ahead and inject the user details as well.
So should we set up some users?
Let's skip the, it'll automatically generate a user details with a password, but we're gonna do a generated password, but rather than hunting through the logs, for that generated username password, we'll just go ahead and put one in here right now.
Okay, so I'm going to use an in-memory user details manager. That's an implementation of user details service, and it's going to be great for storing things, you guessed it, in memory. So pw.role user.build, and then we'll do one for Rob here. Okay, and you can be an admin.
Ooh, I feel privileged.
Mm-hmm. Rob, okay, there's this. And here we go. So there's our basic in-memory user details manager, and that'll provide authentication, right? That provides an answer to the question, who is who? And I'm using a password encoder because we don't ever store, even in a demo where I'm doing things live and you can see the password, you still don't use plain text passwords. It's just wrong, right? So we're going to have a password that we encode, and to do that encoding, we need a password encoder. I guess you could imagine that, right? So here we go. Return password encoder factories dot create delegating and password. Okay. Do you want to talk about that one?
We'll talk about that in just a little bit.
Okay. So 127.80.80 log in. Name is Josh and put is the password. Okay. And so if I go back to there, you can see it's authenticated. Fantastic, right? So, and if let's just, without authenticating, do I get anything? No, I get a 401, right? Yeah, 401. So it's completely locked out if I don't have a token in a session somewhere. Okay.
Yeah, it's good.
Add anything to that?
Let's go ahead and see. Like, one of the things that's interesting is this is in memory, but like a real system, we might do JDBC. You want to show them how to do that? You think that's easy?
So again, we wouldn't even, once you've gotten the basic demo working, I think this is going to quickly outlive its utility. So instead, let's move to something more real. Now, I think the core thesis here is that you shouldn't be using passwords. But if you're going to do them, there's a way to do it correctly, right? So let's do that here. JDBC user details manager. I'll use the data source. Okay, like so. And, okay. Now I happen to have a SQL database that's running in the background there. And it's already been initialized with some schema files that we got from the Spring Security project. It's in the jars. It's a, what is it? Schema -- Postgres, something like that. You can find them in the jars or the documentation. And so if I go to that database here, history, grep p SQL, Okay. This one. Okay. That one. Okay. Now, I've got select all from users, right? And I've got some users and passwords in there. But the passwords are, what are ththese passwords?
They're SHA-256.
How's Spring Security to know that?
Yeah, well, it doesn't. But you know what's interesting is, the other thing is like, what do we do if something's hashed in some old style? Do you think we might have a slide to help explain that, Josh?
Yes. Should I do this first?
Sure, why not?
Do that part, okay, and we go back.
You broke
over.
it. You shouldn't have done that first. I'm just kidding, we can do that.
No.
Okay, we're good. We alluded to this a little bit just a second ago. SHA-256 is kind of broken these days, but you know, why is it broken, and like, what is the history of passwords? And I'm glad you've asked, because I'm going to tell you about it. So back in the day, people used to think, oh, plain text passwords, totally fine because I have it behind a username and password, right? So it doesn't really matter if I store password in plain text. Well, combined with other exploits like SQL injection, people were able to get dumps of passwords, and then they were able to see those passwords, and they would be able to hack users. Not ideal. So they decided, well, what if we ran these through a hash like SHA-256 or MD5, and then instead of comparing a password, when someone submitted a password, we'd run it through the same algorithm and then compare those two values, and if they're the same, then the password's the same. If the database leaked, all they had was a hash with the password. Well, the issue with that is that people created rainbow tables. And anyone here know what a rainbow table is? Okay. So a few people. A rainbow table is basically, rather than attacking a single password, people just created these lookup tables. They ran all the passwords through the hashing algorithms, and they stored them, and they published them to the internet. So if you saw the hash, you could say, oh, this hash equals this password because someone did all the work. And it wasn't very practical for a single password, but it was very easy if you're attacking all of them and sharing it with everyone. So people decided, well, what can we do to get past that? Well, we did salt. Anyone here know what salt is? Okay, yeah, so a lot of hands. Salt is basically, rather than just running the hash password through the hash, you created a secure random number of bytes, concatenated it with the password and ran that through the hash, and then stored the salt alongside the hash password and salt. And so when you compared it, you looked up the hash password and the salt, and you ran whatever they submitted with the salt and compared the two, and if they were the same, then the password is the same. But now hardware is extremely fast and efficient, and that's good and bad. So the bad news is that you can do billions of hashes a second, which means you don't need rainbow tables. You can just attack the password using good hardware now. And so what we've done is now we store passwords in a one-way adaptive function, and that's like bcrypt, scrypt, etc. And those algorithms are intentionally resource intensive. And what do I mean by that? Well, they're taking CPU time, they're taking memory, and they're designed to take about 1 second per password. You can tweak them, right, by passing in the work factor. And so they're intentionally resource intensive, but you run into this weird scenario of like, I don't know the password, so how do I get from my SHA-256 to my new algorithm of bcrypt? Well, Spring Security provides this password encoder that has these prefixes. So if it sees a SHA-256 prefix, it will follow one way of validating the password. If it sees a bcrypt prefix, it will follow a bcrypt way of validating the password. So that way you can have multiple ways of validating password simultaneously and hopefully get your users on newer algorithms. But how do you get them onto these newer algorithms, Josh?
Well, let me go back up here. Here's the thing that has like a dictionary of algorithms mapped to prefixes, right? It's called the delegating password encoder. And you can see, like, it's going to look for SHA-256 as a prefix. And if so, it'll use the standard password encoder. If it finds SHA-1, it'll use message digest password encoder, etc. And the default in a modern Spring Security app is bcrypt, right? But it's going to encode all passwords that are in the database, and it's going to look for those prefixes, and hopefully it'll arrive at the bcrypt one. Okay, so will this work? Let's just see if we've got everything working. Get out of that. Okay, go over here. 127.80, Josh, and then Pua. There you go. So I'm using SHA-256, and select all from users, and that worked, right? But it's still SHA-256. So the question is, how do we migrate?
Yeah. Do you think you could show us how to do that, Josh?
So we've only
Is
got
that a lot of work?
Yeah. Well, it used to be a little bit of work, but now thanks to the new Spring Security, you can do that, right? So now reload, reformat. And now I'm going to do the authentication over here. Okay. Authenticate again. And now when I go over here, select all from users, when we authenticated and when Spring Security had the plain text password in memory from our transmission from the client, it knew that that plain text password matched the thing that was hashed encoded in the database. And it said, okay, well, I know what the correct password is. I'll re-encode it and then store that back to the database for you, right? So now as people log in, they get migrated automatically to much better encoding. So even if you have legacy encodings from the distant past, or not well advised today.
And you might ask why that property exists. On JDBC, a lot of people have password widths of, say, 25 characters, because they're like, who would need a password longer than 25 characters? They're legacy systems, right? Well, you can see these hashes are quite long. And so without that property, if we surprise people, they would have a broken system. So you need that to explicitly opt in for that.
Yeah. Okay, so good. So password, this is how you would do passwords if you're going to do passwords. But should you do passwords?
Well,
Are there better ways?
Yeah, there are better ways. Would you like to show us any?
Yeah. Well, okay. Do we have anything we add here? I don't know.
Oh, we do. We could do that first.
Okay.
Yeah.
Go back to that.
Oh, no? So Josh asked a very important question of like, are there better ways of doing passwords? And we talked about that 1 second optimization that you do for the trade-off. And that's what I want to highlight here is there's a trade-off between securing the password and actually using the password in production. You think about it, if you're trying to prevent someone from hacking it, you want a longer amount of time, but your user's waiting that amount of time for the password to be validated as well. And what's more is malicious users can use that for denial of service attacks as well, which is not ideal either, right? Like you have something deployed to your production system that's intentionally resource intensive. People can bring down your system if you're not careful. So it's like you got to tweak those parameters. So what do we do to like get around that? Well, using a username password for every request, not a good idea. Why? At best, it's going to be 1 second, right? Because that's how fast your password validation should be optimized to. So instead, you need to exchange it for some sort of credentials. And even when you do that, like the password still exists and it's still fragile and people can still steal it. People follow bad security practices. People click on phishing links. And so there's better ways that we can authenticate other than passwords. And one of those might be on the next slide, magic links. Anyone heard of magic links or one-time tokens?
Oh, so
okay, so good. So magic links have...
Next.
Yes. Maybe I didn't need that clicker. Here we go. So basically, the user basically says, send me a token to a predefined endpoint. And that endpoint might be like an email or a phone number, something that's only in possession of that user. And presumably the email or the text message is only going to be accessible to that user because they have some sort of way of authenticating to the email system or to their phone for SMS so that only they can access it. But they can do anything they wanted, right? It could be biometrics. It could be all sorts of different ways to authenticate to those systems. User clicks on that link, and then it authenticates with the token. And the nice thing about that is the URL already points to the right domain, so it's much harder to do a phishing campaign, right? You send a phishing link, it goes to the wrong domain, well, they don't actually have the token, right? So ideally, they're not doing that now. People can be tricked, hey, copy paste this into this URL, or check your email and then go to this. Like there is social engineering in there, but it's a lot harder and it's a one-time token and it expires. So if it gets compromised, it's a one-time thing. And ideally, if it's been a while, it's been expired. So Josh is going to go ahead and show us how to do this in Spring Security now.
So okay, so we've got to now concern ourselves a little bit with authorization, which is again, what rights does the person have? And the reason we need to do that is, for the moment, we want to reintroduce the authorization rules that are already in place and then add some more around one-time tokens. There is a new feature in Spring Security 7 coming out in November of this year or late October.
Yeah.
There's a new feature in Spring Security which is too early to show just yet, but it allows us more granular configuration, so you can contribute basically callbacks that override just one aspect of the authorization. But for the moment, it's a small monolith. It's a mini monolith. It's a monolith, I don't know, whatever. But okay, so there's no word in English for that, I just noticed. That's a bummer.
Should invent one.
So security filter chain, here we go, HTTP security. Throws exception, yeah. And we're going to say return HTTP security. Now the first thing is just to reestablish the defaults that we had before. So we're going to do form login, customizer with defaults, great. We're going to do HTTP basic, customizer with defaults, great. We're going to lock down all the requests, saying that any request, no matter who it's from or where, is required. We require it to be authenticated. And then finally we can get to the one-time token stuff. So we add that. And here we've got this nice little callback, and our job is to configure a success handler. So add that there, and there we're going to provide a response. So here's the one-time token and the request and the response. We say response dot get writer dot print line you've got console mail. So the idea is that you're going to send an out-of-band communication, like you mentioned email or SMS or something. So it's something to which they probably have access exclusively, right, hopefully. Yeah. And certainly Google or your telco or whatever probably has done a better job of making sure your password is secure than your company has the resources to maintain yourself. So the idea is that if you can send them a text message, well, it's much harder to, it's not impossible, but it's much harder to get.
For this demo, though, we created our own protocol called console mail. Exactly. And you'll see how it works in just a minute, but it's very secure.
Very, very secure.
Very secure. So for the sake of demos.
So content type, media type, and you just it's a servlet API here. You can do whatever you want, right? I'm just going to send a response there. var URL or var message is please go to HTTP localhost 8080. That's this thing right here. Login OTT token equals, and then one-time token dot get token value, and I'm just going to print out that message accordingly. Okay. So
console mail.
Yeah.
Right?
Very easy. And of course that boils down, it distills rather nicely thanks to the Lambda syntax here. Yep. So there you go. Okay, so let's try that. We'll restart.
And if you're doing this in a real app, you probably just forward to another endpoint and handle it in your Spring MVC controller.
Mm-hmm. So I've now got two options in the white label sort of login form here for username and password and then one-time tokens. I'm going to say, it says you've got console mail, redirects, and I print out over here, please log in to localhost 8080, login OTT, blah, 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 click on that, and I'm authenticated, okay? So that's much better. And of course you can imagine that would have been an email or something instead of a console, obviously, right? Well, that's good. I like that.
I like that.
Yeah. But it's still, there's a password somewhere.
Yeah, there's a password. As we said, it could still be phished. Social engineering can still happen. So what is something else we could do? I think we might have a slide for that. Yeah. So who here's got heard of passkeys? Yeah. Who here's used passkeys? Ah, good show of hands. Okay, great. So passkeys are based upon a protocol called WebAuthn. And I'm not going to get into a ton of details about how they work because Josh is going to show you how they work very easily with Spring Security. Know that there's a little bit of a dance going on. You ask for some options from the server. You use those options to register a credential. And then you do a very similar thing whenever you're validating those credentials. But the good news is you don't really need to understand how that works in great detail. One thing that is helpful is understanding how signing works. So if we have this agreement, Rob will pay Josh $20, I sign it, and then Josh signs it. What are some problems with this in the real world? Well, how do we validate the signatures? Well, people look at an ID, right? The ID is issued, and we trust the ID because it has some sort of stamp on it, and then it has my signature and picture. But the problem is when I validate that signature, I can actually use it to craft a forgery, right? Like this red signature is no longer Rob's signature. They just used the ID or an existing signature to produce something that says that Josh is getting $2 million. And the other thing is like you can't prevent tampering with this. Like The black is the original text, but someone could add in exchange for his house. And now I get Josh's house for 20 bucks, right? So the good news is using asymmetric cryptography, we can prevent both of those things from happening using a public key and a private key. And the private key is how we validate, or sorry, how we produce the signature, and the public key is how we validate it. And so that way, as long as we keep our private key private, we can let anyone validate that we signed something without them being able to produce a signature. And I just explained all of that there. And then this is showing in a little more detail, and I'll leave it as an exercise to you, how to go through how this all works. Josh is gonna actually show you how it works if you're using Spring Security.
Okay. And this is one of those rare occasions where the result is both more secure and also just more, there's better ergonomics for the people using it, right? It's a win-win. There's no reason not to consider this. This is also not a hypothetical, is it?
No.
This is here today. It's already every major browser on every desktop, on every platform, mobile or desktop, Windows even. Windows, can you imagine? The technology today, it's amazing. So yeah, it works everywhere, even there, which
that's amazing.
Amazed me, amazing. Yeah. So okay, here's what we're gonna do. We're gonna set up WebAuthn, okay, nice little convenient builder there, and I'll just say a.allowed origins, and I'll say HTTP, perfect, thank you, AI, and we'll do RPID is just localhost, and then RP name is whatever, it's arbitrary here. Okay, I've got that. Oh, that's not gonna work. I need one more thing, a nice new thing that's also in Spring Security, the newly added dependency, which will give you that very set of technologies that you need to make this work. So I'm gonna just reload the build. Reload, here we go, sync project, restart. Okay, nice, go back here, take that out, Command-Shift-I. There we go. Now I've got 3 different options. So I have to log in and set up the passkey. But once I've done that, from then on down, I can then use the passkey to authenticate, right? So I'll just, okay,
If you had it from the beginning, you could do it at registration time if you wanted. Right. So this is just a way to add it to existing users in an existing system.
Okay, so I go there. And on the Mac, your passwords are stored in your passwords app, right? So I go here, I'm gonna delete my existing passkey. It's in the passkey section there, yeah? And I'll say MBP 2024, register. And there's 2 different flows here. One is you can do, let me get my old QuickTime going here. Get some movies, movie. Okay, yeah, you can see me. Okay, and so okay, if I want, put that over there. Hold, please. Well, okay, well, there, okay. So I can do I don't trust this terminal. This is like an untrusted device, so I don't want to enter my fingerprint or my Face ID or whatever on this device, but I do trust my phone. Well, I can do the iPhone thing and do a scanned photo. I can scan this, so, well, let me see. If I put that there, right, save a passkey. Now, you can't see there, but it's trying to do a sign-in from that, right? Whoops, come on, computer. And eventually it's gonna ask me to do a Face ID, fingers crossed, Wi-Fi permitting.
So while that's going on, one of the things that it does in the protocol is make sure that the phone is actually located close to the laptop. So it does this through a series of things like Bluetooth connection with the laptop and various other things. And so there is some proximity there. And sometimes, due to conference luck, that negotiation fails. So we might end up doing it with the laptop itself,
right.
Which it can actually trust because it knows it's itself.
This is my device. That's fine. So I'll try it with. I'm just gonna use the magic of the finger here. Ding. Okay. So now I've used that, and that's all I need. That's my biometric. There's other ways, YubiKeys, there's external hardware things. I mean, there's all sorts of different ways to set this up. In this case, I happen to be using the Apple ecosystem, so there's a public key in iCloud and it's federated. So now, in theory, I could use my Face ID on my phone and access the same web app, right? So let's go see that over here.
Because that passkey is synced through his iCloud account to his phone and to his laptop.
Using my finger again to get, There we go. There we go. So I'm now authenticated with this application. Isn't that nice? That's so much better. So much better. And again, it happens to be the Touch ID on this, but it can be Face ID on something else, and it's all good. And you can use your password manager. Your favorite password manager will support this and all that.
Yeah.
As well, you can use Android. I'm sure they have a similar scheme as well. So it just works. Okay, that was good.
That was good.
But
what does that leave to be desired? What about APIs? Can we put in fingerprints when we're calling REST APIs, or
it's going to be
one time?
tedious.
That might be kind of challenging.
So we need OAuth, right? I think
I heard it's a thing.
Okay,
yeah.
So let's take this application and turn it into an authorization server, an OAuth authorization server, where people can then, this thing will vend tokens, and then we can use those to pass them around as in API calls.
I like that.
Okay.
I like that.
And this is not hard to do. When I set up the project, I made sure to add the starter for the OAuth 2 authorization server, the Spring Authorization Server. And so now I just add one little line here. I'll just say with, and I'll say authorization server. Okay. And there's that. Come on, computer. Okay. I had it and I let it go. Okay. Whatever. Maybe if I just pretend it's not a problem. Hold on. Computers are strange. And it's when Joe's here. Okay, authorization server. Hold on. Come on, static import. Aha. Okay. OIDC, customizer.with default. Great. So now I just restart. And now I've got a full-fledged OAuth authorization server. I don't have any registered clients, though. So I need to actually add some clients to the build. And you can do that programmatically, or you can use some configuration. I happen to have some configuration here. Well, at least I hope I do.
By programmatically, he means there's a JDBC support. You can persist it, or you can use an interface for discovering that configuration, et cetera.
Oh, yeah, right. So cat. Okay. And it'll be, source, main, resources, application.yaml. Copy and paste all that. So I'm just going to use the convenient built-in configuration here to register one single client. And you've seen something like this when you go to developer.yourfavoritenetwork.com, right? And you can register clients there. Okay. Now I can prove that's working by going to localhost 8080, well-known OpenID configuration, right? So there's the stuff that makes it a full valid OAuth authorization server. Great. But now I need
all the other moving parts.
Right. If I build an OAuth authorization server and I don't use it to lock anything down, did I actually build an OAuth authorization server?
No, of course not.
Of course not.
Of course not.
So we're going to build a new service here. Back to the lab again. So back to here, start.spring.io. And this time we'll build a new service around dogs, because dogs are good. So data JDBC, Postgres, the resource server support, GraalVM, DevTools. What else do I need? 4.0. Make sure I have that. Okay. And that seems like enough. Yeah?
Yeah.
Okay. Open that up. UAO dogs.zip. Okay. So just a simple application to load a database of dogs. Okay. So we'll say at controller, at response body, class dogs controller. And we're going to have a domain model, int ID, string name, string owner, string description. Okay, and we'll do @ID, and we'll have a repository. And by the way, I love Java records. Look at that. Look how nice that is. Isn't that nice? Such a big win. Okay, so interface dog repository extends a list of CRUD repository managing entities of type dog whose primary key is of type integer. Okay, and okay. Okay, now git mapping dogs, collection of dog. Okay, and return, and we'll just inject the old dog repository there, add that to the constructor. Go down here, this dot repository dot find all. Very good, okay, and put that there. I think that's it. That's basically enough. Now, this is a API, but I don't want people to be able to access this without, first of all, we need to connect to the data source, so secret. And then I also want to make sure that they can't access this without a token, right? So let's set that up in a second here. And the URL will be jdbc:/postgresql local localhost my database, and then we'll do a issuer URI, right? The resource server, pointing it to the authorization server that we just stood up there, so on 8080. Is that okay to you?
Yep.
Okay.
That's good.
And we want this to run on port 8081 so that it doesn't block the same port as the other one, right? Did I already do that? I didn't. Server, port. Did they change the property? Is it gone?
I was just do port. I don't know where it is.
What happened to the port? Wait, did I forget to add the web stuff? Oh, good catch, everybody. Okay, Spring Boot starter web. Oh, couldn't have done it without you.
Disaster.
Whew. You won't get far building web services without Spring Boot starter web. Without that, you're just lost. I mean, it's just sad. So we've got now a web service, but again, it's been protected by this filter that's going to deny access to anybody who doesn't have a token. And that begs the question, where do we get the token, right? We need to incept that token. Something has to initiate the OAuth dance and vend the token, and that's where we get into a client. So let's go back to the old initializer here. And again, take your time, really, it's okay, we're not waiting. What's happening here? Somebody torrenting, get off my Wi-Fi. Oh, thank goodness, look at that. Okay, 4.0, and we're gonna say client. We'll add the web support. We're gonna add the HTTP client support, that's a new one. Right? That's it. Remember, we modularized Spring Boot 4, so now there are new modules that are kind of useful. For example, before, if you wanted to use the REST client or the REST template, that came with the machinery to set up Spring Boot and Tomcat and MVC and all that stuff. Now they can be separate. You can have just the REST client, there's Spring Boot Starter REST client, and then there's also Spring Boot Starter Web. These are two different things now. So if you have a batch app or a stream app or something, and you want to make a REST call, fine, you don't have to start a Tomcat or whatever. But I'm gonna bring in both just because I can. We also want the OAuth client support, and we also want, I think that's it actually. I mean, DevTools, surely, right? GraalVM, but I think that's it. Yeah?
YOLO.
YOLO, whatever. Yeah. Okay, so we're gonna build up that now. And by the way, for people who are wondering, I have a little script on my machine called UAO. It's a Java script. It's a script written in Java. It's the only good kind of JavaScript, right? It's very important to keep that in mind, very important to understand the difference. Okay, so client application. So we want to talk to the service that we just stood up. We want to talk to it, but before we can talk to it, we need to get a token. So we need to act as an OAuth client, which means we need to tell the Spring security machinery how to act as an OAuth client, and I happen to have that code. So, okay, secure, what is it? Desktop, maybe? Cat, desktop, secure all the things. Client, source, main, resources, application.properties, take all that, okay? So there we go. So it's gonna run on port 8082, and this is the mirror image of the configuration that we saw a minute ago. This is not the configuration on what clients exist for the auth server. This is instead to be communicated by the client to the auth server to tell it as what client we are acting on behalf of the user. And so here, we're acting as the client called Spring. And now we're going to try this two different ways, right? We'll do it the old-fashioned way. So we'll say dogs client controller, okay? And we'll have an endpoint that just returns dogs client. It'll return the data returned from calling the downstream service, okay? So dogs, and we'll have a sort of client-side peer here, int ID, string name, string owner, string description, okay? And we're going to say return, and we need the REST client, so private final REST client, okay, HTTP, okay, add this to the constructor. Here we are, this.http.get.uri, HTTP localhost 8081 dogs, yeah? Dot body, and a new parameterized type collection, there you go, add this, very good, yeah? So we're just making a network call using the old REST client, our old friend. And this is almost going to work, but we need to configure a few things on the REST client itself so that it knows how to initiate and then handle the dance to get us a valid token. So I'm going to configure here a request interceptor, a new OAuth 2, that seems right. And then I'm going to inject the manager here, Alt-Enter, please, okay, create parameter, Alt-R, nice, okay. So that's part of it. I'm telling Spring Security, hey, whenever you do a request, run this interceptor, and that in turn will handle the dispatch between the auth server and this if there's no token present. And then finally, when I make the request in situ, as I make the request, I need to communicate attributes, okay? So it's attributes up there, I think, right? Attributes, there you go. And it'll be client registration ID, okay? Spring.
This is so it knows which access token to include. You don't want to accidentally include one from Google to Facebook, for example.
Right.
Right.
Okay, so now, if everything's gone to plan, I should be able to go to 127.001.82. Now, why am I using a different host and port here? Why am I using 127 instead of localhost? I'm asking you, you have to help.
Oh, I thought you were asking the
No.
audience. Oh, man, I'm supposed to know things.
Yeah.
It's because if you're on if ports do not isolate the cookies, which is a strange thing about browsers. It's only the host. So by putting a different host there, you don't get a collision with the authorization server's cookie and the client's cookie.
Oops. Be careful with your forward slashes. It's pick one or the other, but be very consistent. Okay, so take 5. Okay. There we go. So now I'm redirected back to the client. Now, of course, this is the client, this is the data I'm getting from the downstream resource server that's protected with the resource server. But let's say I wanted to predicate, I wanted to filter on just the responses belonging to the user who's in the request, right? Well, let's say I go back to the resource server here, okay? Dogs, and I want to add a new method to the finder here, to the repository, collection dog, find by owner, right? There's a column called owner, string owner, okay? And now I can use that in my controller here. I can inject the current authenticated user, and I can say find by owner principal.getName, okay? So this is the service, this is the REST API, the backend API that has no, user-facing thing here. I make the same request, and now you can see that this is, since I authenticated as Josh, it's only those records that match Josh, right? And if I log out, do that again, now I'm going to log in as Rob, PW, and then you can see that now I've got only the dogs that have Rob as the owner, right? So the client doesn't know that I'm doing all that, matching of tokens and so on behind the scenes. Okay, one more thing.
One more thing?
One more thing.
Oh,
we can make this
I like
simpler.
that.
There's a nice new feature in Spring Framework 7 and Spring Boot 4, built on a feature that was nice in Spring Framework 6 and Spring Boot 3, which was inspired by a feature that was in Spring Cloud OpenFane 15 in 2015. So it's a long time in coming, but it's really quite nice. What we're going to do is we're going to refactor this code to, instead of using this direct client in our gateway, in our bridge, we're going to instead create a declarative interface-based client. Where's the controller here? It's all this. I did the logic all here. Look at all that code. Oh. I just want to get rid of that, right? So let's build a client. Class dogs client, okay? And I'll call this an HTTP service client. I'll have get exchange, and I'll make the same call. There we go. Okay. And then I'll do collection of dogs. And I need to client registration ID, Spring, same thing, right?
Interface.
Class, thank you.
Yep.
Interface. And then, this stuff, I can just delegate to that, can't I? So I can comment that out and comment this out. And I need to do one more thing with one more bean I need to register. Give me a second for that. Okay, we're going to inject the dogs client, add this, and I'll say return this.vada, okay? And then finally over here, this we don't need, but we need to do the same thing in effect, don't we? So we need to create a bean OAuth 2 REST client, this one?
Yep.
Okay, this one, and then we say OAuth 2 configurer.this, and we say manager, and create parameter, Alt-R, there we go. So I'm gonna return that, very convenient. That's basically it, right?
Can I show a little symmetry here real quick?
Sure, but can I run this?
Scroll down to the interface.
Yeah.
So if you look, it says client registration ID. That's the same thing that we were setting as an attribute. So now we're just setting it using an annotation.
Right.
That's the only difference from what was happening before.
And in the controller, I'm delegating to that underlying interface. Okay, so now, same as before, it just works, right? So if I log out, dogs, client, Command-Shift-I, this time I'll log in. Did I reset this? I don't know if I reset. Let's just do it.
Yeah, I don't think you can. We don't have passkeys set up because we restarted the server, so.
There you go. Nice, huh?
Yeah.
Much easier to get better security, better ergonomics, better scalability, better everything.
Now, of course, if we'd reset up the passkey, we could do the exact same thing, passwordless from the client, redirect it to the authorization server to get the access token. It would prompt us with the passkey.
We can do
and
the
then after
Touch
it
ID.
gives us the passkey, it would give us an access token and an access token to the API. So the whole stack would be passwordless.
Should we try it quickly? We have like 1 minute. Well, we have 30 seconds. Let's see here.
He's waving. He's like, no, you can't.
No, we got it.
Okay, he says we can.
I mean, okay, so we're gonna go to web authn register.
Oh, you're going to have to do it with localhost.
All right, localhost.
So another thing about passkeys is it helps prevent phishing attacks. So if the domain is wrong, doesn't match up with your configuration, it's not going to work. So that's why you have to stick with localhost here because that's what we configured for the passkeys.
Deleting the existing one so we don't have an issue. Okay, take 2, register, speed run the security. Okay. That's so much faster than those typical, sign-up forms and all that. So I want to do 8082. I want to do 127.8082 dogs client incognito window. Log in with a passkey. Use the finger. And there we go. I've got the data just for Josh with the power of the touch, right?
No passwords the whole way.
Yeah.
Yeah.
Thank you so much, everybody.
Thank you.